first thing first? Homework questions. Did anyone have trouble calculating either the side or the angle of a particular question? Yep.
I forgot what it's called though, so what about the kite? Like, each tree has a kite. How tall?
Oh, so you're getting to the word questions already. We'll get a chance to see stuff like that in the actual lesson.
Okay.
So hold on for a second. These are questions in preparation for our quiz next class. Given a triangle, can you calculate sine or angle? Right, like I give you the picture. Going once.
Can we have a review?
All right. So let's get some wild questions down, okay? So I have a reason. Okay, let's get some wild questions down. That's a nice, decent triangle, right? Again? Again? Didn't you say? No party. Didn't you say? Right? That I could trust you? That if you were never going to be late after again, I would bring my teaching equipment and we would have a
Yeah, on Wednesday we'll have a quiz.
And we can vlog it.
No.
We can vlog the party.
The promise was from that day on.
Exactly.
It's from the quiz.
Your fault. Okay. All right. Some numbers. I don't care what the numbers are because we can make it work. I have a right angle triangle. In fact, I have two.
What?
Yeah, that's right. Well, this one will have an angle. That one we won't have an angle. But both ways we can make it work. Give me two numbers.
4.
8.
4 and 12.
6 and an angle.
36 degrees.
33. Great. How about this one? I'll make that the angle. Give me two sides.
8.
8.
13.
13. Where should I put 13?
Hypotenuse.
Okay.
It's got to be longer than E.
Okay. So I want this one. All right. If I want the unknown value for x, number one, you have to label each side as either opposite, adjacent, or hypotenuse. So go ahead. Right off the bat, the 90 degrees will tell you that this side is the hypotenuse.
The adjacent side.
This side is considered hypotenuse because, well, you know this from elementary school. We have the furthest side from the angle called opposite angle. Opposite side. And that makes sense. The remaining third side right here, so opposite, hypotenuse, it happens to be right next to the angle of interest. And another word for right next to?
Adjacent.
Adjacent. Right on. So from there, step 2. Which of those three sides doesn't help us? Which of those three sides do you want to use, and which of those three sides do you not want to use? You have to establish that. Okay? And just give me a quick reason why.
So I want to use opposite hypotenuse because I have a variable for one and a number for one.
Right? And this one is useless
We don't know
because,
anything about it.
yeah, we don't know anything about it. Opposite, hypotenuse, go through your little mantra, and you realize opposite and hypotenuse are only found for that one, which represents sine. Sine of 33, and now my big picture, take out your calculator, is equal to opposite over hypotenuse, or x over 6. And that's it. People who are away, simple enough. You just gotta sort of go through the motions. I'll repeat it one more time. Figure out what each of those three sides is labeled as. Number 2, figure out which one of those three we are not going to use and the other two we will. Match it up. Yes?
Don't we have to solve it?
Yes, of course, of course. So sine 33 will give you a ratio, a fixed ratio. I don't quite know what that is off the top of my head, so someone's going to have to calculate that for me.
0.5446.
0.5446, and there's a good reason why I ask you to have more than just 2 decimal places. Try to have as many as you can until the very end. How do I get x all alone? Very quick. Yes, both sides have to multiply by 6 because obviously this is a division of 6. multiplied by 6, which means this would be about 3.276. Yes. Okay? Which rounds to approximately, if you want to, 3.27. There it is. So that is about 3.27.
And that's the length?
That will be the length of this value index, yes. If I were to reverse the process, okay, we want to find this. Which of these three, I guess, ratios uses adjacent and hypotenuse? Someone who wasn't here. Let's get you on board. Someone who wasn't here last class. Let's get you on board. Who wasn't here? Most people here. Most people here. Liz, you ready?
Not really.
Very quick. We need adjacent, we need hypotenuse. That's A and H. What letter is in front of the A and H?
C.
C. That represents cosine. That's all it is. Cosine of an angle is equal to adjacent over hypotenuse, which is actually 8, 13. For this case, there is one more step you need to do. I need to reverse the ratio. I need to go backwards and say, if this was my ratio, what is the angle that will give me that ratio? And this is where inverse cosine, or old school arc cos, that comes in. So, with your calculators, figure that out. Somebody is going to have to help me
So
out.
when they give you the angle, already, you just do the functions of that angle, and then you can find out what the side. Oh, when you're figuring out the angle, you have to do the inverse, but when you're figuring out the side length, you have to.
Sure. I don't like to simply divide it as if you have this, you do this, if you have to do that. I don't want it to be an instructional. Right? That's not the purpose of math.
Can you find the side length without having the angle?
Only through maybe Pythagorean theorem. But
of course.
yes. But the whole purpose of this is to see that there's a relationship between angle and side, so it might be useful to have both. Okay? Yes.
The answer is 52.02.
50.
2.02. So basically it's 2.02.
Okay, so approximately 52.02 degrees.
Yeah.
That's 52.02 degrees. It's because we know that there's always a relationship in a right angle triangle. Yes? Sure. I'll say it one last time. You're just murmuring, I'm sure you're talking about the math that you didn't want to be up here. If you're using opposite and hypotenuse, take a look at the letter that this starts with. O. And the letter this starts with. H. There's only one out of these three that uses both O and H. That's it. Same with here. A and H. There's only one out of these three that has both of them in the same, I guess, acronym. And that's how you know. Yes?
Why can't we just use hypotenuse and the adjacent? Why can't we use those two for the first question over there?
For this one,
Yeah.
you don't know anything about adjacent.
What do we know about the opposite?
Well, that's the number that we want. That's what we were trying to figure out.
So
So we know it's a number x.
right.
For this one, no variable, it's pretty much, you can say, we're uninterested in it. It's not going to get us anywhere. Okay? Questions? Okay. While I go about erasing the board and getting us ready for next this following class, anyone wonder why the focus on triangles? Why the focus on triangle? Yep.
Because they're the simplest.
Possibly. Now we can argue, some people can argue, well, what makes something simple?
Because calculation.
Okay, that's calculation. What makes a shape simple? Number of sides? Because you can say if it's a number of sides, can't I argue that the circle has just one side? It's not straight lines, and straight lines are easier. Possibly. Possibly. Some people might disagree, but I'll leave it at that. Anyone wonder? Remember, isn't the whole point about math not just listening to the teacher, but sort of asking yourself questions like why? No? Yeah. Hang on. Pass that. Okay. Before you take a look at this, I actually want to talk about that concept. Why the focus on triangles? Here's an example. Well, let's go back. Am I wasting your time with triangles? Please say no. Please say no. Maybe. Look around. What is the most common shape you see in this room?
But triangles, squares are made of triangles.
Okay, so triangles can make up squares.
Because it's triangles initial shape of the angles that makes up everything.
Can we extend that a little bit? Triangles can also make. What's the next shape that you think of? Sure, an octave of 8. So we jump from 4 sides to 8 sides. Okay, what's in between? Hexagon, sure, that's a 6. Okay, hexagon can be made of triangles. I'll demonstrate it. So it's like pentagon. What else? Octagon we just mentioned. No? Alright. Hexagon, anyone know? Grade 10 chemistry. What's the next prefixes? Latin prefix. Nona, nona, yeah.
Decagon.
Decagon, good. You wanna know 11?
Trigon. I feel like it's a triangle.
Just waiting for someone to mention some kind of book.
That's 111.
11 again. Alright, people. Take a look at your drawing and see if it's somewhat similar. It could be flipped. You could have drawn the wall on the left side, but it should be somewhat similar to this. We have a ladder. According to the instructions, a ladder must make a 65 degrees with the wall, or with the ground, sorry. And if it doesn't, well, you can imagine it's going to topple over. Anyone anyone know Home Alone? You guys young enough for that?
Yeah.
Okay. Yeah. So there's a lot of traps that the hero sort of sets up in an attempt to rescue and save the house, right? Just think about it that way. The closer the ladder is to the wall, right? As you climb it, the weight will raise up and then it will slowly topple over. So in that same way, we need the ladder off the wall so that it won't topple over. Where is 15 meters going? Where is 65 degrees going? You need to be able to interpret it. So, sorry, Alexia, I'm going to pass on. I need someone who is sort of, tired. I want them to wake up with it. Lindsay?
I think the angle has to be like between flat and ground.
Yes, right? It says it must make 65 degrees with the ground. So you have no choice but to believe that it is this way. You have to make that assumption, okay? It's not supposed to be rocket science. Don't think too hard about it. You're probably right. 15 meters. Where's that going?
It's the ladder.
It's the ladder itself. Good. Okay? Everyone see the triangle? Okay? So let me just do this very quickly. This is the only time I will do it. All the other times I'm just going to move on and do the calculations without having to transfer. The question is, how high can this ladder reach safely? In other words, I'm trying to look for this side of that triangle. So let's do it. Step 1, label. Yep.
So the ladder is the hypotenuse.
Good. And this is?
Opposite.
Good. I don't even need this because you know that you won't ever use it. OH.
S.
Good. Sine of the 65 degrees is opposite over hypotenuse, which I'm simply going to rewrite as x over 15. You need your calculator. I need x all alone. First, or you know what, let's work around it. Let's get x all alone, which means both sides going to multiply to 15. I have x is equal to 15 times sine 65. Now's a good time to check. If you have a business calculator, you are doing it a little differently than someone with a scientific. Help me out here. Grab a calculator, let's do it.
Oh, wait. What's the 15 on the other side then? Wait, I'm so confused. I'm so sorry.
How did I get the 15 on the other side?
Oh, never mind. 13.59. No,
I like the harmony. 13.59. I don't have a calculator, and I don't know if that is correct. However, does it make sense? Well, if this was 13.59, does it make sense that it is slightly smaller than the hypotenuse?
Yeah.
I would say yes, and only slightly smaller because if this is 65 degrees, that's a pretty large angle. Realistically, 65 degrees is probably going to be about that. So if that's 15, this should be pretty close to 15. So if I did this drawing properly, it'd make more sense. But I think I'm on the right track. You know what I'm saying? Don't just blindly trust your calculator. Take a look and see if it's realistic. Let's move on to number 2 because although it's the same question, it introduces 2 new terms. Now, if you're in my grade 9 class, I know that you know this, but I'm still gonna go through it. Ivy sits 15 meters away from a building, which is about 13 meters high. Okay, this is as realistic of a building I can get it. This is going to be 13 meters high, and this person right here is sitting 15 meters away. Angle of elevation. Intuitively, I think you have an idea of what that looks like. Yes?
Already solved it.
No, we're not there yet. Too soon.
That's like how she's looking.
Yes. So here it is. Angle of elevation, angle of depression. I'm going to only say it once, so everyone listen up. When you're looking at something, like, let's say Kyle and I were having a conversation. We are looking at each other eye to eye. We're talking, okay? That line of sight, you can argue it is parallel to the floor. Wouldn't you agree?
Yeah.
It's horizontal, right? It's like perfectly parallel. Now, all of a sudden, let's say there's a bird that's flying over Kyle and it starts takes a dump on him, whatever, right? If I am to look at that bird, what's happening to my head?
You're creating an angle for the floor.
Oh, you're getting really tight. I'm just tilting, okay? I'm just tilting my head. That angle that I tilt, I elevated my head. I elevated my line of sight. So we call this an angle of elevation. If you're a little bit curious, just think like Daddy Shark, okay? Okay? That's your angle of elevation. In the same spirit, if I refer to something as angle of depression,
Angle of oppression.
not oppression, the angle of oppression. Wow. Thou shalt bend the way I. Okay, no, that's weird. Okay? Angle of depression. So it's going down. In the same way, I'm looking at Kyle, I'm looking at his shoes now. Okay? The angle that I look down will be my angle of depression.
That makes some sense.
Okay? Mommy shark. Okay? So if I say the angle of elevation is what I'm looking for, it says, what angle of elevation must she use to see the top of the building? Long story short, if this is my line of sight, my angle of elevation means I am looking up, and this is the angle I'm interested in.
So tan.
Because they're looking up.
Yeah. So then you label it
Ivy
and
is
find out
not,
if it's
her
tan.
eyesight is not on the floor.
Very good. Now she's thinking. She's thinking realistically. I appreciate that, Lindsay. Unless Ivy is like a 1 centimeter tall person, the eyesight is not going to be on the floor. You are absolutely right. Until the question mentions how tall Ivy is. Let's just simply make the assumption that it is close enough to the floor that we're not going to think too much about it because the building itself is 15 meters tall,
Okay.
13 meters tall. You know what? Realistically, you're right. And so if I were to try to sort of design a question like this for a test, I might say like the angle that like the foot makes or something like that. I'll try to be specific, but it's a good thought. So, now that you've set up, let's label the sides. Same as before. Opposite, adjacent, hypotenuse?
15 is adjacent, 13 is off,
Okay.
the other one is height.
Right, and you don't have to go there because I have two sides I already know. O, A,
O divided by A is tan.
tangent of an angle that I do not know yet gives me a ratio of 13 to 15. So, if the angle gives me this ratio of sides, what is the angle that I started with? You have to reverse the process, or in this case, do an inverse tan of 13 over 15.
It's 40.9.
40.
40.9.
Point
9.
9. Something like that. Again, I'm not quite sure, but I sort of agree because 15 and 13 are very similar. And anyone off the top of their heads, if I had, let's say this was 15 and 15 and this was a isosceles triangle, what would these angles have to be?
I'm gonna guess 18.
30.
Square root.
No, it'd have to be 45.
Oh, sorry, slide line.
Oh, okay, yes, you're right. It would have to be 45. So, being very close, I would say this angle is also very close to 45. But it's just a thought, just a passive thought. Just make sure your answer is realistic. Lastly, because we already talked about angle of elevation and depression, there's one more thing I want to review. How to label triangles properly. Let's see how much you remember from elementary school. Okay, the corners of this triangle is labeled A, B, and C. What would you describe the opposite side of angles? What letter would you give the hypotenuse length?
D.
H. D. A, B, C, D, E?
B.
A, B. True, A, B. But let's say I'm too lazy to write A, B. I want a single letter.
D.
D. Anyone? Anyone?
E.
Little c. Why? I'll explain. The side opposite of A.
Oh.
Little a. And opposite of B? It just makes it easier because I know exactly what side I'm talking about. Which is, to be honest, this is where the first steps of learning what the opposite side is starts in your math career. So in trigonometry, when I say what's the opposite side, it should be automatic. If it's not, maybe it's because this wasn't really talked about too much. But anyways, with that same spirit, if this was U, W, V, and right now I'm actually doing number 4A, okay? How did I know these were the angles? I don't know where U and W is, but I do know that it says
V is 90.
V is 90, that's why I placed the V here. So, which side is little u? Little u. VW is little u. What's little v? Yes, good. And that leaves me with little w. Now that we know what each side is labeled as, what are some of the distances for number 4A? Little u is 10.3. And little v? So 11.4 is not this. 11.4 is the hypotenuse, but they never said it was hypotenuse. You have to be able to figure that out. Right? You'll see some of this, okay, in the future. So you get some more practice, angle number 4B, number 4C, you can get some practice with that. Let's find length W. Now, right here, some people might, a bell might ring in their heads. I'm looking for side W. Yep. You could use Pythagorean theorem. What would that look like?
A squared plus C squared equals C squared.
So?
10.3 squared plus W squared equals 11.4 squared.
Okay, equals 11.4 squared. That's it, just because I'm going to get you to work on that. Don't yell it out. For everyone else, just because we're on the section of trigonometry, what can we do?
Guess.
My life is a lie. No, we're not guessing.
You can do cosine.
Okay, so Which angle are we dealing with then?
W.
Good. Okay. Everyone listen up. Marco. Let's pretend this is my angle. If that's my angle, we have adjacent and hypotenuse. Cosine of an angle would be adjacent over hypotenuse, which means the angle is inverse cosine of. Yeah. Someone's going to do that for me, please. Quick. Someone with the calculator. Someone that's not lazy. Someone who loves me. Please. Silence. No, go for it.
25.3.
25.3 degrees. Okay. If this is 25.3 degrees, that's my opposite side. Which one of these two do you want to use as my other side? Hypotenuse or adjacent? Jackson? Doesn't matter? No? You don't care? No, just choose for me then? Adjacent. So we got opposite, we got adjacent. Out of those, oh shoot, I erased it. Out of those three ratios, we should be using
S. Oh, no, I like T.
tangent. O and A. Tangent of that degree is equal to opposite over adjacent. What is W? In other words, multiply both sides by 10.3. Someone else, just get everyone next to that. People should be grabbing their calculators. Even if it's on the phone, just try it. You gotta practice this. It's next class, okay? It's next class. So you know what people?
We skip question 3.
Yes, we do.
We're multiplying 10.3.
Yes, this should be some number. We're multiplying both sides by 10.3. So what's effectively happening is this.
And 10.3 on the right side is just out.
Well, you multiply 10.3 on both sides.
I thought normally you do the tangent of 25.3 first, and
You
then
can. Nothing wrong with
But
it.
you're just pretty much right on the bottom line.
Yes. What's the answer? God, you have to process. Help me with the answer.
Oh, I just don't.
Sorry, say that again, 9? 4 point?
4.868. You have the whole thing.
And one more? 8.
Oh, no, 7.
7. Lexi?
Close enough.
What is it?
I got 4.89.
89. Okay. Probably because there's some rounding involved here and here, but this is where I wanted to get to. Pythagorean theorem, trigonometry, it's part of the same world. Pythagorean theorem strictly stuck with the sides, whereas trigonometry, we've involved angles, but they're still talking about the same triangle. Okay?